can find the sun, and if you see the sun, you can point it out to your neighbors. Anyone see the sun?
Yep.
There it is. There it is. Anyone see the red dot?
Yep.
All right, red dot's me. So it allows me to point things out. So what am I circling? The sun. That's right. We are looking at the sun over there. We are 1 week away from an eclipse, and that's when the sun will be hiding. Which is right now we don't see the moon. The moon is a little below the horizon. We'll see it a little bit later in our program when we get closer to a sunrise. So this is what our sky looks like, although right now I'm pretty sure our sky looks a little bit more like this. Outside, a little cloudy. I haven't seen a window in a while, so it could be sunny. I don't know. But here in the planetarium, I can control the weather. I can make it nice and sunny instead of rainy. And in order for us to see the nighttime stars, I am going to have to get the Earth to do a little bit of spinning. So this is when things get a little twisty-turny. We'll just watch right now as the sun goes down, which is, again, our part of the Earth turning away from the sun. So as it is going down, you'll notice other things that might pop into view. I'm just going to lower my robot a little bit, out of the way more. You can come up at the end if you are curious. That robot is what we used to use for the stars in the dome. We now are fully digital. So now you're probably seeing some dots in the sky. Most of these are stars. Only one or two of them might have been a planet. So the way you can tell the difference between a planet and a star is stars twinkle. As the light comes from far, far away, that light bounces around in our atmosphere, and it looks like it kind of twinkles. Just like the star says. Lovely song, Twinkle, Twinkle, Little Star. However, if you found yourself a planet, you look at a solid bright dot that is not twinkling. And if you can find that before I label it, you probably have good eyesight. So our planet that is not twinkling is Jupiter. Over here in the western sky, it will be setting not too long after sunset in the coming weeks. As we are all going around the sun, at some point we will not see Jupiter anymore. We'll see it again later on in the season. So that's where it is right now. I can do a telescope cool thing where I zoom it up and make it look awesome like a actual planet. So that's part of the fun of being in the planetarium. You can control a lot of fun things like that. So at the moment I am going to show you that this is not even all of the stars that we can project here in the planetarium. We're actually only showing you maybe the top 50 or 100 stars right now. You want to see all of the stars?
Yes.
Okay, this is when it's going to get darker. And as it gets darker, if you feel like it's too dark for you, it's okay to tell me. I'll put some light back. But I want to show you all the stars, and it's easier to see without the extra light pollution. Light pollution comes from building lights, street lights, and car lights. When those lights go up into the sky, it blocks out the stars. We're just seeing the bright ones.
Whoa.
Let's imagine ourselves in a time without that light pollution.
That's cool.
There we go. That's a lot better. So now we can see the thousands of stars that are hiding behind those city lights. And so now your brain is probably trying to play connect the dots and having a little bit of a hard time. And that's okay, I'm going to help you out. So what is the first picture that you like to look for when you look up at the sky? Call it out. What do you think?
I like seeing all of the exploding stars, or like
Ooh,
the ones that are
exploding
like big and giant.
Those are cool. All right, so big red stars. Any other star pictures or star shapes that you know of? Yes. I could. You want to see a star up close? That would be really cool. But right now, I'm not going to zoom up a star, but I can highlight a very favorite group of pictures or group of stars that people like to think of as a giant spoon in the sky.
Mm-hmm.
So the giant spoon I am talking about is Big Dipper. So if you look high above your head, you'll see this giant spoon. Although from this angle, it looks kind of like a kite flying in the sky. And it does have 7 stars, and those 7 stars are pretty bright in comparison to some of the other stars. They are not the brightest ones. There are some other brighter stars out there. But they are pretty bright, and you can see them any time of the year. You might see them at different times or different parts of the sky at different times of the year, but it's mostly up in the north. And so this group of stars, people said looks like a plow. Some say it looks like a person. Some say it looks like many people, so each star represents a different character in the story. And some say it looks like a bear. And I'm not sure how they got bear. out of these 7 stars, but I'm going to help you out with some imagination drawings. So here is how we turn a spoon into a bear. Not a good bear? Okay, let me try again. Alright, so here is the bear.
Oh.
So Ursa Major is the formal name for this group of stars. And so Ursa Major means big bear. Now, if there's a big object, that usually means there's a smaller object. So we're going to have to look for little bear. All right, so let's take a look for little bear. We're going to take the spoon, at the edge of the spoon of the bear, and we're going to follow it down into the sky. We land on a star called Polaris. Polaris is the North Star. That is the star that doesn't move. The North Star is very different from all the other stars because as the Earth does all the turning, that star stays where it is. All right. So hold on one sec. We have someone coming in. So the North Star is the star that doesn't move, as we mentioned. And do you see any other stars that are out there that are brighter than that North Star?
Yes.
Yeah.
Yes. So that tells us that that star is not the star you should look for. So the North Star. Hold on one sec. There you go. One moment. So let me show you how we can find a little bear. Here you go. Ooh, sorry about that. All right, so now we turned a spoon into a bear. Does that look like normal looking bear? What's wrong with my bears? I had 2 bears in the sky. It's got sharp claws, they got the ears, they got the teeth. What's wrong with my bear?
The tail.
Oh, are bears not supposed to have long tails?
No.
No. Yeah, I know. I've been to the zoo a few times. I have not seen bears in the wild, thankfully. But most of the bears I see usually have short, stubby little tails. And so those tails in the sky are because of a superhero that got things a little wrong. So a long time ago, people were really bored. They did not have TVs, they did not have video games, they did not have computers. Instead, they went outside, they played Connect the Dots with the stars, and they came up with some really interesting stories. Now these stories, sometimes were silly, sometimes they made sense. So imagine your superhero finding 2 bears in the city and then grabbing them by their short, stubby little tails. Now these bears, grabbing them by the tails, start swinging the bears around their heads. Now our superhero is really strong, so he can swing round and around and around. The tails start to stretch and stretch and stretch, and finally our superhero lets go, thinking he's going to send them out to the woods. But our superhero was too strong, and they end up getting stuck in the sky instead. And so that's how we have long-tailed bears in our sky. The superhero at the time could have been someone like Zeus or Hercules, but it really could be any superhero, so you can make it your own as you wish. So these 2 bears are always in the sky. They just might be chasing each other around in circles throughout the year. But this is where we find them in the springtime. In the northern part of the sky, we also have another constellation known as Cassiopeia. And so we take the Big Dipper, follow the lines out to the North Star, and we keep going. We land on the W. W stands for Cassiopeia. Cassiopeia is a queen sitting in her chair. She thought she was prettier than everyone else. The gods weren't too happy. They threw her in the sky. That is the shorter version of the story. The longer version involves sea monsters and some flying horses and some other superheroes. But Cassiopeia is also always in the sky, and depending on what time of year, you either see her right side up or upside down. So those are some of the pictures we see in our northern sky all year long. We call them circumpolar constellations because they go in a circle around the pole star. In comparison, we do have pictures that we see that will change from season to season. So what is the season we just ended? It involves snow. Winter, yes. What is the season we're in right now? Spring, and our future season is? Summer. So our past season, winter, all of those pictures are going to be seen in the western part of the sky near where we saw the sunset. And so those are the ones that are right over here, including this guy that I'm circling right now with his fancy belt. Who has a fancy belt?
Orion.
Orion, yeah. So Orion's fancy belt and 4 stars that go around it. That's how you know you're looking at Orion and not someone else. Orion is seen here with his fancy belt. Here's Orion. So fancy. And he's seen holding a shield and a sword because he's a warrior up in the sky. Now, this fancy belt is useful because it can help us find 2 bright stars. One of them, if you follow his belt going this way, leads us to the brightest star in our sky called Sirius. And Sirius is seriously bright. It's also the brightest star in our sky. So if you compare it back to the North Star, you'll notice that Sirius is really bright and the North Star is not so bright. But it is bright enough in its area, that's how we know we're looking for the North. But if you followed Sirius throughout the night, Sirius does move, so that's the problem with following Sirius. You'll get seriously lost if you thought it was the North Star. So, Sirius is the bright star in the constellation Canis Major, which means big dog. And so this is the big dog, Canis Major. If you follow Orion's belt in the other direction, going this way, we get to this red star here called Aldebaran. Aldebaran means bullseye. What do you think the constellation will be for Aldebaran?
Bull.
A bull. Yes, Taurus the bull. So here's Taurus the bull's head with its horns. And you can see Orion is fighting off Taurus the bull. And so these are some of the winter pictures. We'll see them for a little bit longer, and then they will go below the horizon, and we won't see them again until next winter. So let's talk about our springtime sky pictures. Now, the Big Dipper was easy to help us find the North Star in Cassiopeia. We're going to use it to help us find 2 other and possibly 3 other constellations, depending on how we imagine our sky. So we're going to take the Big Dipper, so find our Big Dipper once again. Now I want you to imagine the bowl here has a hole in it. And that hole's going to dribble water out going in this direction. And you land on a star right there. That star is called Regulus. Regulus is the heart of the lion. So here's a lion. And if that doesn't quite look like a lion, no worries, we got the picture for you. So Leo the lion is up there in the sky. So Leo tells us that spring is here. That's how you know it's springtime. And so that is using the spoon to find Leo. Now we can use the spoon to find another person in the sky. We're going to use a different part of the spoon. So we use the bowl to go this way for the North Star, that way for Regulus. This time we're going to follow all the way around to the arc of the handle. Now if you arc with the handle, you end up on Arcturus, that red star there. That red star, Arcturus, is really awesome because it's part of a constellation. If you saw on your map something that says Boötes, although you might be looking at booties, but Boötes is supposed to be a person who watches over bears. I don't see a person who watches over bears when I look at Boötes. I see something else. So this is the bottom, one side of my item. This is the other side, and we got the scoop on top. So one side, other, and a scoop. And to me, it looks like ice cream. And of course, most ice cream cones always have that dribble coming out of the bottom. That's what's coming out there. But it is the giant ice cream cone of summer. When I see this giant ice cream cone of summer, it tells me summer is on its way, and I'm super excited because ice cream is what you see in the summertime. Now, people a long time ago didn't have ice cream, so they didn't draw ice cream in the sky. They drew a person. What was your question? You want to see the person? All right, so Boötes is a person and he is a person who watches over bears. So let me see if I can find it. There you are, Baotis. See, I don't know how they got that out of the stuff. But somehow, this is Baotis, and the sky person who watches over bears, and he's right next to those bears in the sky. But for me, I see food a lot because when I do the show, it's usually around snack time or lunchtime, and so that's why we got the giant ice cream cone of summer way up there. So another thing we can do after we find the big ice cream cone of summer is we can find spica. So if you arc the handle towards first, and then you spike down to spica, spica is right there, and spica gets you to the constellation Virgo. So here's Virgo. Virgo is supposed to be a lady lounging in the sky. So here's the lady lounging in the sky. It's one of those that almost looks like it's good, but maybe a little bit more. So spica is actually that grain of leaf that she's holding on to. So Virgo is one of those constellations that tells us when to plant and when to harvest. So when you see Virgo up there, it's usually around the time you start planting. So that's early spring. And when Virgo sets the end of the summer, or later in the summer, that's when you know it's time to harvest. And so before they had calendars, they used the sky as sort of a way to remind themselves of when to plant and when to harvest. And they knew certain stars and certain constellations came up at certain times of the year. And so that was just their way of remembering. All right, so now I've showed you some constellations. I'm going to show you all of them. So people filled the sky with their imagination. Now, these are the constellations that are drawn up by the International Astronomical Union.
Wow.
They took constellations from the Greeks, the Babylonians, and then some modern astronomers they threw in as well. And they filled the sky with all kinds of weird things. Sometimes the pictures make sense, sometimes they don't make sense. They drew people, animals, mythological creatures like unicorns and dragons and giant serpents. And then they drew things that are normal. And things that they saw in their everyday lives, like compasses and sextants. And a triangle, because someone really wanted to draw a triangle in the sky. So we have triangulum over here on the right-hand side. Yes, there is a constellation known as triangulum. It's exciting. So as you look around, you'll see that, again, people fill the sky with their imaginations. This is just how some people see the sky and their pictures. People all over the world have their own constellations, and they drew pictures in the sky a little differently from one culture to the next. So this is just the ones that the International Astronomical Union decided to use as their basis for map drawing. They don't use the constellations the way we do, in the sense of storytelling. They use it more as a zone in the sky. So they knew that if there was a nebula to look for, they should look in a specific area of the sky. So for example, someone wanted to see what happens to stars when they blow up? Yes. So in over here, Orion, these little 3 stars here are not actually just stars. That area, if you aimed a telescope at it, you would see a nebula that would look a little different. Something like this.
Whoa.
So this is what Hubble would see if it was looking at that spot with a few extra cool filters. And so what this is a baby star forming region. So stars form, they all kind of, material kind of gathers together, clumps together, and enough heat and pressure you get a star. Which, in the opposite sense of things, when those stars die, they can be releasing out material into space, and it looks a little something like this.
Whoa.
So this is what happens when a star about the size of our sun will kind of release its outer layers into space. And we create something that's this. We call it a planetary nebula, even though there's no planets in this view. They just kind of called it that because it looked a little bit planet-like, even though it was actually a dead star. If you have an even bigger star, you get something more violent of an explosion, kind of like this one.
Whoa.
And these are kind of bright to look at. But this is the Crab Nebula. It's called the Crab Nebula because someone said it looks like a crab. I have no idea how to get a crab out of this, but that's their imagination. But this is what happens when a bigger star goes into supernova. So this is kind of the leftover evidence of a larger star, larger than our own star. And so there was a time when people around the world saw a weird extra star in the sky. They called it a guest star because it arrived and then not so much time later, it disappeared. And so that was actually this supernova, leaving a very bright remnant behind. And so they actually did some math in recent years. They figured out this is where that guest star was. So stars live and die in many different ways, and our star has 4 billion years to go, so don't worry. Our star is good. But it is kind of cool to see how other stars are, and around the sky, there are lots of areas where you might find nebulas. So either the nebulas where stars are born, or a nebula where a star has died. And so those are some cool things to look for. And sometimes you'll also look and find things like galaxies. Now, you might have wondered what this fuzzy stuff is. Did anyone notice the fuzzy stuff?
Yeah.
Yeah, that fuzzy stuff is our galaxy. The Milky Way that we live in, that's the Milky Way. So Orion, with his shoulder here called Betelgeuse, Sirius, the bright star here, and Procyon, that bright star there, part of Canis Minor. These 3 stars make up the winter triangle, and through that winter triangle is the outer edges of our galaxy. In the summertime, you'll see a brighter center of our galaxy, because that's looking toward the center. So it looks brighter when you look toward the galaxy in the summertime than when you're looking at it in the wintertime. Any other question? What's your question? Inside a star? That's an excellent question. So I can show you that once we get our sun back up. So we're going to have to get later into the night and then back into morning time for us to show that, okay? All right. So let's get our Earth moving again. I kind of held us at a couple hours after sunset. I'm going to move us till almost midnight, and then we'll kind of keep going until we get to the sunrise. So this movement that you're about to see is our Earth doing the turning. I just speeded up a little faster. And 3 hours are going to go by in 30 seconds starting now. If this motion, as you're looking up, looks a little dizzying to you, it's okay to close your eyes, no one can see you. But we're going to work our way to a sunrise. So this is the slow round, and then we'll eventually get to a faster round when we really speed up our sky. So you'll notice how some pictures are going up in the eastern part of our sky, other pictures are going down in the western part of our sky, and the stars in the northern part of the sky are just kind of going in circles around that North Star. All right, that was it. That was the whole movement of 30 seconds. So you can see Orion is now lower, our Big Dipper is now higher, and I still have more hours to go to get ourselves to the sunrise. So we're going to go till 3 o'clock in the morning. Again, 3 hours, but this time it's going to go faster. 3 hours are going to go by in 12 seconds. So this gets you dizzy. So close your eyes, starting now.
Wow.
Whoa. All right, so now that Orion's down, Scorpius is now up. And Scorpius is the scorpion. They're always chasing each other, being chased. And so here is Scorpius the scorpion. There's the scorpion. And toward the center of that, where its tail is, that is the center of our Milky Way. In this time of night, so 3 o'clock in the morning, this is our summer sky preview. So here's our summer triangle. So our winter triangle points out the winter edge, the outer edges of our galaxy. The summer triangle points out toward the center of our galaxy. All right, it's only 3 o'clock in the morning when you should be sleeping. But if you're not sleeping and you wanted to get to the sunrise, we're going to do again 3 hours in 5 seconds. So this is when it's going to go really fast. 4, 3, 2, 1. Woo! Almost sunrise. So what's now up?
A moon.
A moon, yeah, and a couple other planets. So just before sunrise, you can see some planets. If you're up early enough, I'm just going to zoom up the moon because it's fun. And we'll zoom that back. And I'm going to let our Earth do some more rotating so we can get our sun all the way up. And someone asked to see the center of our sun, so we're gonna do it. Alright, so what goes on inside of sun? Okay, we're gonna pause right about there. Now our sun, let's see if we can go inside. Okay. Let's do a quick cut out of the sun. Let's see if it's there. Yep, and now we're gonna do a quick go to sun. It's gonna get dark and we're gonna go into space. So hold on just a second. So inside our sun, we'll fly out over here. Normally don't fly during sky shows, but it's kind of fun to do something different. So in the center of our sun, where that red dot is, that's where atoms are smashing straight bigger atoms, so hydrogen smashes into helium. And then that heat and energy keeps moving its way out through the star and eventually gets up to the surface. And so that's what those arrows are pointing, that heat and light getting out to the surface. And then it takes 8 minutes for it to go from the sun and make its way all the way back to us where we can see it here on Earth. So that is what happens when you get close to the sun. Normally there's no bites taken out of it, but if you wanted to see up close, that is what's inside. It's just really bright stuff. Please do not go outside and start staring at the sun. The sun is too bright. This is a safe sun here in the planetarium. And the safe way to view things like eclipses is by not looking at it.
And
So if you have solar eclipse glasses, that's one way to do it. If you have like a pasta strainer that has big holes in it, take a pasta strainer and then hold it over to your side, and then you can look at the shadow of that hole. And those shadows, the holes that are in the ground, will be actually the sun projected through those holes. So that's a fun thing that you can do without looking at the sun. You can look at the shadows that other things create. So that's a fun way to explore the sun safely. So thank you all for joining me in our sky show. I'm going to bring up the lights a little more. And as I mentioned, we do have star maps here at our desk, so you're welcome to grab a star map on the way out. And if you do have questions, I'm happy to stick around and answer for questions. And I hope you all enjoy the rest of the day here at the Science Center. Thank you all for coming. Our next show will be at 2:30.